So when we think of behavior-driven development, we only think of Gherkin. Gherkin is a business readable language which helps to describe a business behavior of an application without actually going too much into the details of the implementation. So it's more like a documentation of the application, and sometimes it acts as a skeleton for automated testing. A Gherkin syntax comprises of certain keywords, for example, feature, scenario, given, when, and then, background. These are certain keywords which are used in a Gherkin syntax, and these are plain simple texts which help in clearly articulating what the end user is supposed to expect from that particular feature. Now let's have a quick look at these two examples. Both these different styles of writing a feature are pretty popular. The first one is essentially um, an imperative way of writing, and the second one is a declarative style of writing. The first one basically is more detailed than the second one. If you look at these two features carefully, they explain or represent the exact same scenario. That is, whether the process of checking out from an e-commerce website is successful or not, right? But if you look at the first example, every step of the implementation is detailed out in the scenario. It talks about entering the username and the password, clicking on the login button, then clicking on the add to cart button, and then the steps after that. So it is very intrinsically attached to the actual implementation of the application. However, if you look at the second example, which is the declarative style of writing, you would notice that it essentially explains how a user, a business user, would look at the process. It says that uh, the user is logged into the account, he has added a product to the cart, completed the checkout process, and then he should get a success message, right? Or something like that, a successfully completed the purchase. Now, this is more business oriented. The benefit of a declarative way of writing is that it does not get restricted to the implementation of the application. So today, I have the application which is working well, but tomorrow, if that application is changed, if the UI changes, for example, if there is no more a login button and suddenly I see it's a submit button or a sign in button, then I'm basically making sure that with a declarative way of writing, my underlying code, my underlying tests might change, but the overall behavior of the application does not change. And that makes it way more robust than imperative way of writing. Another problem with the imperative style of writing is the usage of examples in a scenario outline. Say, in this application, we have the details of entering an address, which is probably the first name, last name, and only the zip code. But in other applications, you might have to enter addresses which have, let's say, the street name, building name, and many other fields. That essentially makes the entire examples table way more longer than ideally it should be. And that makes the readability of your scenarios not so user friendly. And that somehow diminishes or devalues the actual business scenario, and does not entertain the business users anymore. So that's one big drawback. So it's important to understand that an example or the examples in a business scenario or scenario outline is different from the test data. A test data is something that is intrinsic to your test. It varies from environment to environment. So for example, here in a test environment, I would have standard user, but in the acceptance environment or a higher environment, I might have standard user one. So the data might vary. Does not mean that my feature files should also change per environment. Also, the test data sometimes is generated from an external source. Sometimes it is generated at random, dynamically at the time of execution. So, a test data is different from how examples are used. So, if you look at it overall, a declarative way of writing feature files is more prudent than an imperative way of writing. With that out of the way, we would move forward to write a feature file, and then we would want to import it into Kits and see how to take it forward from there. See you all in the next video.